Hello, everybody. Welcome to the S44 CitrineOS webinar. My name is Olga Zimonich-Haygood, and I am the executive sponsor here at S44 of the open source initiative CitrineOS. Really appreciate everyone joining today and hope that you will find our discussion both informative and useful as you embrace your electrification objectives. I wanted to take just a few minutes to walk you through what we will be covering today, as well as to introduce the S44 team behind this content. So we will talk very briefly about S44 and how we got to this electrification focus. We will share some insights from the road and from the real world in developing EV charging solutions, which led to this innovation and necessity for an open source offering. We will walk you through CitrineOS features, functionalities, and roadmap, as well as share our insights as they relate to the transition from OCPP 1.6 to OCPP 2.1 or 2.0.1, better yet. And lastly, we are hoping to help you contextualize how CitrineOS can be leveraged and how it can be used to support your business objectives. In addition to the S44 team, we are joined by several of our partners, namely Stackbox out of Germany and Pionix, also out of Germany. They are very active in the open source space and also contributors to many of these charging solutions. We are going to reserve approximately 20 minutes for Q&A at the end of the hour. We ask that you submit your questions via Q&A, and we will do our best to get through as many as we can. Following the Q&A, we'll be sure to share contact information for any future follow-up or additional questions that you're looking for us to answer. So without further ado, I'll take just a few minutes to introduce my team. Thana Paris is our Director of Open Source, CitrineOS. She is also a Senior Software Engineer here at S44, deeply steeped in all topics pertaining to electrification, OCPP, and OCPI. Manuel Belshak is our engineering manager as well as cloud expert. Together with Thana and the broader team, he has been involved with our CitrineOS solution, but also managed several development teams over the years who have worked on custom software for EV charging. And so what he will offer today is really those real world insights, which I think many of you will be able to relate to. Jason Cardozi is our head of sales. And the reason we have included him today is because when we announced CitrineOS in Q4 of 2023, we have subsequently been fielding quite a few inquiries looking to better understand what the open source solution offers and discussing various business cases which we feel are probably relevant for the balance of this group today. So Jason will be sharing a little bit about how we can leverage Citrine and where there's potentially opportunities to both contribute and to partner with us on implementing it. So let me take just a few moments to give you a little bit of a background about S44. We have been around for approximately 12 years. Previously, we were Sulzer US, a division of a originally German company, Sulzer GmbH. Our legacy experience was supporting automotive OEMs with a number of custom software development solutions. But approximately 7 years ago, we decided to expand our focus and essentially start shifting our focus towards solutions that can really help transform electrification. We were very lucky to work with a number of OEM leaders in Europe and the United States, where we saw not only their organizational agendas mirror kind of where the market was moving, but also their technology needs informing kind of where we place our focus. And so, as I mentioned previously, having done a lot of this work in the real world, we pursued the open source solution, focusing on OCPP 2.0.1, and really, looking to share that with the world in hope of helping advance, electrification agendas. So we believe that this real world experience really made us very uniquely suited for such a solution. And in addition to that, our team has been an active contributor to the EV Roaming Foundation out of the Netherlands, where we are collaborating with many others in the space, looking at existing protocols and how they need to evolve. And then lastly, shortly after launching our open source solution last quarter, we submitted it for consideration to the Linux Foundation Energy, and we're fortunate that they unanimously accepted it. And so CitrineOS is now part of the project portfolio of Linux Foundation Energy, And we are incredibly excited both by the enthusiasm from the developer community as well as through companies that are interested in both contributing to its evolution as well as using it for their proprietary solution development. So, why did we do this? Many of you will relate to this immediately, but we found that the world was ready to embrace EV charging, but business wasn't necessarily experienced in such a way to be able to anticipate and prevent inevitable silos with implementation of these types of technologies. And so for us, the true objective was to say, how can we revolutionize this sector through an open source solution, and how can we offer that to the world? And we did that obviously as well because in a lot of instances, both in the United States and Europe, there is a very big focus on achieving sustainability goals through things like reduced emissions, and doing so through electrification and expanding EV adoption. So, in addition to being pretty well versed in those policies, what really stood out to us is incredibly timely with this open source release is the NEVI compliance requirement here in the United States, which mandates that anyone who wants to qualify for government funding to support their charging infrastructure must embrace OCPP 2.0.1 by the end of this month. So, without saying the sky is falling, we thought that this was both needed and timely. And Manuel will speak to you next about some of those real world observations that really led to this innovation and why we are focusing on certain solutions and features as part of CitrineOS. So Manuel, I'll turn it over to you.
Thank you. Okay, so everything started with OCPP 1.6, and now on the market there are like really a lot of CPOs. And on this photo, it's quite clear to see how everything is now, because we have a lot of implementations of CPOs based on OCPP 1.6, and there was not really one standard how to do it. And that was also because of the nature of OCPP 1.6, which left a lot of interpretation, and on top we have built also a lot of custom solution and the other CPOs as well. And that have left to not having one standards, but just like big chaos that have happened. And in the end, that didn't lead to unique charger experience. And so what we have learned is that, as example, there was no standard for management of chargers. Yeah. So how to onboard, offboard, boot new chargers. So that standard didn't exist. So again, it was a lot of custom solutions that have been built on top of OCPP. Then again, one issue that we have faced, and it was really hard to solve, is the scalability of OCPP services, because there was not really easy way to track the communication between the charger and CPO. And we have faced so many times that we would end up with like sessions that were stuck, and it was really hard to solve it. And then we had to build again some hacky and custom things that would actually solve these stuck sessions, because the synchronization between the charger and CPO was really hard to do and to achieve. Then we did like test the OCPP 1.6 and the chargers and cars included. And if multiple cars would come to one charger, they would really have different behavior, because also the software of the chargers and the CPO and car was not really standardized. Then the other big difficulty that we have faced was also monitoring and logging of chargers, which was also really hard to achieve, especially like dealing with charger logs when something went off. And then we had to like have special storages and come with some tricks to pull like logs from chargers and push them to some tools, and then examine that and then build the tools on top of that. Yeah, and I think many of you probably had the similar issues. And then the also big issue which we had was migration between the CPOs. Yeah, since also the OCPP 1.6 left messages not being standardized, and it gave the way to actually have the custom built messages between the charger and CPO, and then to like migrate from like SaaS to maybe custom CPO was like super hard and costly, and it took a lot of manpower. And then to overcome all of that, we think that open source is a way to achieve that. And why open source? Of course, the open source comes with a lot of advantages like community, collaboration, security, transparency, innovation in general, independency, and so on. But one thing that we want to say is that standardization is also a huge advantage of open source. Like we had in history some open standards like Linux and Docker and Git and Kafka and so on. And all of them were like open standards, open sourced as well, that pretty much changed technology in general. Yeah, like Git changed how do we manage source code completely. And they came like open source standard, and people are using that now. Almost every company that you would face is using Git actually to manage the code. So it's became the standard for that. And then, of course, over like years, there are like companies who have built the things on top of that. But the important like message is that there was the standard to manage the code. And the same would go with like Docker and Kafka and so on. There are like many of them that have changed like future and how do we manage things now. So to truly advance EV charging forward, we should and we must embrace these open standards. Yeah? And once we have these open standards, we can pave really huge growth and in the end build innovation on like top of these open standards. And this is why we also want to say that having the standard which is open sourced for charging would do the same thing for tech as Docker did and Git and Kafka and so on. Yes, then now my colleague Tana is going to tell more about OCPP 2.0.1 and so on.
Thank you for the introduction, Manuel. So as Manuel said, one of the reasons that we created Citrine was open source, and the second one was OCPP 2.0.1. I'm going to establish some context as to why that's the case. So you can see on this timeline that 1.6 came out in 2015, and it's seen very wide industry adoption, and is still to this day pretty much the standard used across all charging networks. OCPP 2.0.1 came out in 2020, which is 4 years ago, but there has not been the type of adoption that 1.6 received. The first and biggest reason for this is that it was a major version change. So 1.6 to 2.0.1, a lot of fundamental aspects of how the protocol works changed, and in order to update, it would require substantial infrastructure changes. And it is our hope that Citrine helps bootstrap people into 2.0.1. 1.6 had a lot of issues, as Manuel mentioned, that required the use of some of its custom message types. So 1.6 had a data transfer message that allowed you to send custom messages, and is required for a lot of things that are necessary for a charging network. Whereas 2.0.1 has those messages, and then they're part of the actual protocol and don't need customization. And this is going to allow interoperability of chargers between networks in the future, which is one of the reasons why it's required by regulations such as NEVI. Looking into the near future, we can see that there's OCPP 2.1 around the corner, hopefully to be released near the end of this year. Unlike the jump between 1.6 and 2.0.1, this isn't a major version change. It's building on top of 2.0.1 and expanding its functionality rather than changing it fundamentally. So more of an upgrade. It will be containing new messages types to be used with ISO 15118, expanding the use cases it supports with an eye towards the recently released ISO 15118-20. So between open source and 2.0.1, we felt that there was a great need to create a new solution, and that is CitrineOS, the first open source charging station management system using the OCPP 2.0.1 protocol. So I'm going to delve into the things that you can do via Citrine with the 2.0.1 protocol that are big upgrades over 1.6, starting with device management. 2.0.1 introduces the concept of the device model, which is a high-level abstraction of both logical and physical components of chargers. This includes things such as a security controller, which contains passwords for the charger to access WebSocket connections. It can contain things like a data controller that allows you to manipulate what Wi-Fi the charger is using from over the air. It also contains physical components that represent actual physical aspects of the charger, things like temperature sensors and cooling fans in the charger. This allows the central system to both monitor those items by receiving the temperature or the fan speed, and also to control them by setting a target for the fan speed that could be changed by the central system in any way needed. 1.6 did include WebSocket security to a degree, but 2.0.1 introduces MTLS as an option, which is much more secure. And it allows for the central system to set network profiles and change the network profile in use by a charger, which can be used to change what level of security is being used by the charger, which is useful for development, and can even repoint a charger to a new central system if needed. There's also better transaction handling in 2.0.1. There's backwards compatibility with the meter values system, but there's a new message type introduced, transaction events, which allow for a finer grain of control over what types of messages you receive from the charger and when the beginning and the end of transactions actually are. You can start transactions instead on, say, a parking sensor going off, or you could have them start when a user plugs in or when a user authorizes, and that control was not available via 1.6. One of the things that most commonly needed the use of custom messages in 1.6, you can do out of the box with Citrine via 2.0.1, which is ISO 15118. There are messages that allow you to do plug-in charge transactions built into 2.0.1. 2.0.1 also allows over-the-air secure firmware updates using MTLS. And it also allows you to push images and text and pricing information down to the charger, which again was one of the areas that constantly required custom messages with 1.6. And now it's standardized via 2.0.1, and you can use that via Citrine, and it'll make it a lot easier in the future for chargers to swap between networks. Additionally, the offline behavior in 1.6 was not the best in terms of how it was specified. In 2.0.1, you can control what types of messages are queued so that not all messages are queued. And you can also notice when messages are dropped much more easily, as messages that are supposed to come in a sequence actually now have a sequence number. So say you are in a charging transaction, receiving transaction events, those messages are numbered 1, 2, 3, and if you skip from 3 to 5, you know you've missed 4, which makes it a lot easier to monitor connectivity during a charging session. This is the roadmap for CitrineOS development. And this is very much subject to change as the community grows and expands. We're going to be having our first technical steering committee meeting in March. And there have already been a number of people who have expressed interest in contributing. That could make these different parts be available quicker. And also people have expressed interest in expanding Citrine into areas beyond OCPP 2.0.1. We will have at the end a link to our landing page for Citrine that will allow you to get involved with the community. And we will be publicizing the technical steering committee meeting once it is scheduled. And I hope to see some of you there. I'm going to dive into some of the more technical aspects of Citrine. So it is written in TypeScript, and it's one of the most common programming languages, and we're hoping that makes it more accessible to the community. It is API-based with the module architecture, and I'm going to get more into what that means, but the reason why we made that decision is to make it easy to fit into existing charging verticals and to make it easily extendable. It currently passes the OCTT core and advanced security tests. The OCTT is a testing tool that was created by the Open Charge Alliance, who controls and maintains the OCPP protocol. We are also pursuing an official OCA certification and hope to have that for Citrine in March. CitrineOS is under the Apache 2.0 license, meaning that everything on the GitHub can be forked and you can repackage it with your own IP and use it freely. Citrine was also recently adopted as a Linux Foundation Energy project. This is a architecture diagram of a very high-level overview of how Citrine is structured. There is a central system which receives messages from the charging stations, and then it sends these onto a message broker to be consumed. The different modules that consume the messages also share a memory cache and a relational database, a SQL database. On top of that database is a Directus instance, which serves as an operator UI, allowing network administrators to view and manipulate the data that's being collected by the network. Directus is another open source project, and it's easily customizable, and it contains out of the box a lot of neat features, such as being able to create low code or no code flows that can automate certain things that you're going to be doing with your network very commonly. For example, you can automate certain aspects of commissioning. Simply by filling out one data entry, you could execute a flow that then queues a series of messages, such as a boot notification, maybe some set variable configuration messages that then will be automatically sent when the charger connects to Citrine. In that dashed gray box are the different modules that consume messages from the central system that have been put onto the message broker. And that's where the actual business logic of Citrine is, and where the messages are processed and then responses are created. It's also where the API that allows you to control Citrine and the chargers through Citrine exists. Going deeper into exactly that, the modularity and the API. Right now, there is a module for each different part of the messages that 2.0.1 has in it. These modules are separately deployable, and they can be scaled separately. And we've divvied up the messages among these modules with an eye towards the frequency that they need to be used with. So, for example, transaction event messages are the most frequently sent messages, being sent up to twice a minute, every minute during a charging transaction. And those are received by the transactions module, which then can be separately scalable for modules that handle messages that see much less frequency, such as the reporting module, which would see messages like get base report, which might only be sent once every time a charger boots on, or even with less frequency. The system also allows for third-party modules to be created that can also consume messages off this message broker and send them down to chargers, and those can add additional features beyond the scope of what's already in Citrine. The API that Citrine has is split into two parts. It is split into a message API that allows you to push OCPP messages down to the chargers. This also includes a callback URL, which then Citrine will post replies or associated messages to. This makes it very easy for Citrine to fit into existing backends. So, for example, if a existing backend would send a remote start transaction down to a charger, it could do so with a callback URL that then will have all the transaction messages sent there. The data API is the other half of the API. It allows CRUD operations on information necessary to operate Citrine. This includes stuff like customer authorization. This is an example of a third-party module that has been created that expands the functionality of Citrine. This module was created by Stackbox, and you can see that it feeds off of the message broker, as I mentioned. And through this module that Stackbox has created, you can have a Stripe payment portal for users of Citrine. So these are different ways in which you can leverage Citrine right now. To start with, there's the community version, if you will, the blueprint, which is everything that's on GitHub. As I mentioned, you can add to it yourself to grow the community. You can fork it and develop your own IP on top of it. And you can develop your own third-party modules to be sold as a service to other users of CitrineOS. Next, we do also offer a hosted version of Citrine. S44 will manage an instance of Citrine for you. This includes the management of details like the ISO 15118 certificate chain, which will always be unique to each network and each user of Citrine. And also integration with observability and business intelligence tools of your choice, such as Datadog or Snowflake. It also allows you to have dynamic pricing and over-the-air UI updates for campaigns. And we will help you integrate it into the rest of your stack in whichever way is required. Finally, one of the more unique things that we do offer is a hybrid solution, which is a combination of using CitrineOS yourself and also the custom development of additional features by S44, which is one of our strong suits. We've developed a lot of custom software for customers in the past for CPO solutions. And I have listed here some example cases that I'd like to go into in a bit more detail. Local load balancing is a custom feature that we have seen before. Say you want to have some chargers in an area where you don't have a local controller to make sure that they don't trip a breaker or overpull from the local grid. You can have that controller, rather than be physical, be in the cloud with OCPP 2.0.1, and you can make sure that the chargers have their max power levels set such that they will never trip the local breaker. So say you only have one charger currently charging, that charger can be allowed to have max power. That as additional chargers request permission to begin charging, you can change the max power of the different chargers at that location and make sure that they never trip that breaker. And this way you can have that be in the cloud rather than needing an upfront infrastructure cost to have a hardware solution for that issue. Additionally, say you have some chargers on your network that are having issues with connectors overheating, maybe even lighting on fire. In 1.6, in the old world, so to speak, the first time you hear of failures like that is when you receive a status that the connector is faulted, and that's a bit too late. With Citrine via 2.0.1, you could implement a system that makes sure you get alerts as soon as temperature is higher than a certain threshold. Also, if you have some custom solutions that you need to maintain, don't want to reinvent the wheel, say you already have your ISO 15118 solution and there isn't a great need to use a new one, we can integrate that into Citrine and how it currently operates using that API that I mentioned that makes it easy to fit in to existing solutions. Now I'm going to hand it over to my colleague Jason to talk in more depth about these options and opportunities.
Thanks, Donna. Hey, everybody. Before I start, I'll remind everyone to please submit some questions on the content that you've already seen. I see you still have people joining the webinar, which is great to see. And we should have at least 20 minutes at the end, plus or minus, for some Q&A. So to start, I'll give everyone a quick background on myself before I move into how we essentially implement the solution. I've been working in tech related to mobility, fleet management, connected cars, working with OEMs, building custom solutions, and also SaaS products that truly impact how people move via automobiles. OCPP 2.0 is a standard industry protocol, and CitrineOS was created to help implement that standard and avoid companies falling into problems that are related to building closed proprietary solutions that at the end of the day will inhibit mass EV adoption. We essentially built Citrine to save time, save money, and create consistency across the entire industry. When we explored how to build models that allow Citrine to support implementing OCPP 2.0 at scale, talked to a lot of people, charging networks, OEMs, fleet companies, disruptive mobility companies that were operating EVs, the technology community around electrification. And we knew that we were going to be challenged creating solution models that were going to allow more than just the developer community to adopt Citrine. So we initially implemented 3 approaches derived from real world use cases, feedback from the industry. All 3 allow for easy adoption, quick go to market, support scalability, and will enable the customization desires that we heard in some of these conversations. S44's real bread and butter, as Olga and Thana mentioned, is we've been building custom mobility software for some time and recognize that that can take a long time to do when you go custom, but also there can be expensive, it can be costly to build custom solutions. So on the other side of that, SaaS solutions can be easy to adopt at the start, but can become costly when they are implemented at scale. And in the long term, off-the-shelf solutions can present challenges with customization needs, and they don't always present functionality that's really going to fit every use case. So we created solution models that allow for businesses that normally need to adopt the SaaS product or purchase an off-the-shelf product to be able to use open source and build a custom solution that worked for their needs. So on this slide, we took all that and again created these models so large organizations, small organizations can build on top of the open source, fast, easy, in a flexible manner. And it really doesn't matter, I think, if you have an existing technical stack or if you're building something from scratch. These 3 models essentially can conform to whatever your business use case is. So first and foremost, the one thing that we've really hit hard on today is the CitrineOS community. CitrineOS is code base via GitHub. Think about it as the blueprint of how you build the house, but it's not the actual construction company that is building the house for you. So it's a code base. It's free. It's easy to use. We implore you to contribute to it, and the engagement has been awesome from the community so far. As Donna mentioned, there's a technical steering community for CitrineOS, which starts in March, and we would love to hear and see some faces from this webinar in some of those future meetings. The second approach is really an enterprise approach. We're calling it an as a service model. Note, it's not a software as a service model or a SaaS model, but it brings the benefits of that type of a solution to market. So quick deployment, quick go to market, scalability, design, and because CitrineOS is modular based, that modular solution design really allows for us to build something that's going to be custom to what your specific business or use case needs. Good examples of someone who might implement this could be someone who's operating SaaS today with no native backend, but has 2.0.1 charger hardware and needs a way to operate their network. Or you could be on a SaaS solution today and just simply not ready to make the full investment to build a custom proprietary solution on your own. So again, there's a balance of who and how you could use it. And for I think the majority of the people that I saw who joined this call is, and also I think my favorite approach is our hybrid approach. It's really CitrineOS as a foundation, and we allow the technology to be forked and then built to build custom models on top of what your needs are. And it also allows you to retain the intellectual property rights on those new forked features. So you can build modules or adopt modules into your existing ecosystem due to the modular design, and again, stand something up that's relatively quickly, whether you're again building into your existing ecosystem or started from scratch on a full backend build. Perfect example of how this hybrid solution works really is if you're a network operator or you have an application that's running on 1.6 and you need to transition to OCPP 2.0, then the hybrid approach is really a plug and play scenario for that type of the evolution, if you will. And then the prior slide highlighted our partnership with Stackbox and the payment piece. So there's bolt-on modules of partner solutions that will be able to essentially be added based on a one-off use case or added as the solution or the business scales and calls for additional functionality. So, and I also think that we're big picture open to other types of models that we may have missed. So I'm looking forward to speaking to everybody about those unique use cases and allowing Citrine to really get out there in the marketplace. Yeah, I think in closing, again, I kind of mentioned I had a lot of awesome conversations right when we announced CitrineOS back in the end of October. So I'm looking forward to speaking to everyone on this call, hearing more about how you plan to use it, looking to see the developer community contribute to it, and looking forward to collaborating with everyone here. I think at this point in time, I am right on, leaving us 20 minutes for Q&A. We're on the dot almost.
Thank you, Jason. About 15 minutes. I appreciate it. Thana, Manuel, Jason, thank you, everyone. Just a reminder, if you have a question to submit, please do so via the Q&A box. I believe we received a few already. And for any additional discussions or exploratory conversations, you can scan the QR code and book a time with Jason, if not our broader team. I think the only thing I would add to what's already been said is in the event that it was not evident, even in the situations in which you are forking the CitrineOS base and building your own IP, you will continue to reap the benefits of the open source community as anything is tested, modified, evolved. So that residual benefit is part of the reason why we believe this will be a really good solution globally. So on that note, I know we've received a few questions. We have about 14 minutes remaining. Thana, I'll turn it over to you to address the first.
Sure. So I'm going to start with, I see a question. How will CitrineOS help me to migrate from OCPP 1.6 to OCPP 2.0.1? So migrating from the older version of the protocol to the new version of the protocol has sort of two big components to it. you need to update your charging firmware. So you need chargers that actually use 201 or software for your chargers that allows them to use 201. And then you need a new CPO to manage those chargers. So for the updating your chargers part, there's a variety of ways to do that. You can buy new hardware. Maybe the hardware provider gives you a software update. There's also open source solutions like the one that Pionix has created, Everest, that allows you to update. Once you have a charger that is capable of connecting via 201, the use of Citrine is that it makes it much easier to bootstrap yourself to a complete CPO for controlling those new chargers. So Citrine itself is a functional charging station management system that then you can copy and run in the cloud or use in one of the ways that we've laid out and Jason has laid out. And then you can swap those chargers to that new charging station management system. And there's some benefits of its design that makes this more plausible than simply switching, say, from one software as a service provider to another. The API basis of Citrine can make it easier to fit into a custom hardware stack that you already have. So you don't need to, if you've developed a custom 1.6 solution, you don't need to go back to having a SaaS if you want to go to 201. Instead, you can get yourself your own custom 201 solution much quicker, which is better. That way you don't need to suffer through going to a SaaS and then you need to get off that SaaS again. And I see that's one of the biggest benefits of both having it open source and also having it have this design that makes it easier to fit into as yet another service or collection of microservices in your current backend. Next question I see, how can I test my charger's compatibility with CitrineOS? So there's a few different ways. If you are feeling up to it, you can follow the README that we have on the GitHub. We also have a page, our github.io page, which you can actually see there linked on this slide, that has a getting started guide. This is for the more technically minded, your engineers of the world that can get Citrine started on a laptop. It runs just fine on any old laptop. And you can connect a charger directly to it running on your laptop, and you can test it that way. If you would prefer, we also operate a version of Citrine in the cloud that is specifically for testing interoperability. And you can contact us, you can contact Jason to talk more about that and what that looks like. I also have a question. I'm interested to contribute and join the steering committee. How can I do that? So once we do have the technical steering committee meeting scheduled, we will be promoting it on LinkedIn and in other areas. In addition to that, if you go to our github.io page, there is a link to our Discord. We operate a Discord. Discord's a form of social media. It's an instant messaging platform where you can go and have a community. We have a Discord community specifically for Citrine that we invite you to join. It's the best way to stay up to date on not only things like the technical steering committee, but also upcoming features, pull requests as they're opened to add features. And if you want to ask questions to troubleshoot Citrine or to ask about how you can contribute, that is the #1 place to do so. Let's see also the question, why did you decide to use API approach? So the API, as opposed to, say, having started with some kind of user interface for interacting with Citrine, the benefit is that by making it API first, we're emphasizing compatibility. One of the problems with 1.6 wasn't simply the protocol's design, but the way that people actually used it. there was a lot of very siloed use of 1.6 that wasn't friendly to working as a community and having community implementation of the protocol. I think that the design of Citrine is to democratize this space and make it much easier for everyone to access this protocol. And I think that the API-based, API-first approach emphasizes this, and I hope that it makes it a lot easier for people to figure out ways to use this, to use Citrine. That being said, it being API first does not preclude it gaining some more UI, UX in the future. If that's something you're interested in contributing, for example, or see as something that's very important to you, reach out to us, talk about it on Discord, or talk about it with Jason. It's something that we will expand into as Citrine matures. It's just not where we started. We wanted to start with an API first approach. See a question. Could I use an existing CPMS management tool instead of DirectOS? Yes. So DirectOS is connecting underneath to a SQL database, but it doesn't create that SQL database. It allows you to view it and manipulate it. Anything that can be built on top of a SQL database, any tool you could use with, it would be pretty easy to use. If some specific adaptations need to be made to be used, to use Citrine with the tool that you have in mind, that's a great example of a hybrid solution custom feature that you could talk to Jason about. I see. Does Citrine contain any tools or methods for mocking or simulating chargers and connectors? So Citrine itself right now does not, but we are not the only open source game in town. As I mentioned, there is Everest, which is an open source charging firmware. And Everest allows for us to create a Docker image that you can spin up really easily. And it has a simulator that allows you to simulate plugging in cars, charging vehicles. It's incredibly useful. And we've been using it during Citrine development. And I strongly encourage anyone who wants to simulate a 201 charger to check out their solution and to use it for that purpose. And we do hope in the future to continue to leverage it to do things like load test Citrine and come up with more concrete examples of how it performs at scale.
Okay, Thana, I think we can probably do, let's say, 2 or 3 more questions, and then we can move to closing. I believe Manuel also has something to add.
Yeah, I would say that we did like test and like deployed the CitrineOS and Everest to AWS. We didn't like deploy it to Azure or GCP or something else. And we did like test it with ECS, but due to architecture that was explained by Tana, it's really easy to deploy it to any cloud you want, even on your local machine. So because it's all microservices and events, so it's really easy to maintain and deploy to AWS or GCP or Azure or anything you want.
Thanks, Manuel. All right, let's go back to some more of the questions. Thank you for your questions, everyone.
I see a question. What are the hardware requirements to support the OS? So Citrine was created to be cloud agnostic. You would be able to use it on the cloud solution of your choice, whether that be AWS or Azure. If you mean hardware requirements, as in what types of chargers in particular, Broadly speaking, any charger that has an OCPP 2.0.1 firmware should be able to use Citrine. We are in the process of testing with a number of different hardware providers, and we will be adding those hardware providers on the Citrine page as we do so, as having been previously tested to make sure that the integration works. But in theory, any charger that has implemented 2.0.1 should be able to work with Citrine out of the box.
Any others, Donna?
Any questions? I see. Will the software as a service solution enable other certificate operators like SAE or Charlin? Yes. So right now, Hubject has been the largest certificate authority provider that we've worked with for ISO 15118 certificate management. But we could absolutely in the future support others, both in the software as a service offering as well as a custom feature. Yes, that is something that we are interested in and will do in the future. I think that's it for questions.
Okay. Great. So hopefully this was informative and beneficial to all of you. We do appreciate the time and your questions. We will be attending the upcoming Plug Fest in Germany, February 27th through 29th, hosted by Pionix. And then again here in the United States in Northern Virginia, March 5th and 6th, hosted by DECRA. We are looking forward to meeting many of you who are hopefully going to be in attendance and doing some real-time, testing of Citrine. But as the team here mentioned, we feel very confident that this solution is going to lend itself to really, scalability and helping all of your organizations as well as others in the field migrate towards 2.0.1. So just as a reminder, we will be sharing the recording of the full webinar, and you are welcome to get in touch with us via the QR code should you want to discuss any of the options. We are absolutely looking forward to having you contribute to our technical steering committee via Linux Foundation, Energy, and then of course in GitHub. So thank you so much. We appreciate your time and we wish you a happy Valentine's Day. Have a great rest of your day. Thanks.
Thank you. Thanks. Bye.
Thanks, everybody.